the radars in vehicles. So that's what I did in my internship. After that, I got opportunity to work in a new company called as Candela Technologies. So currently I'm working in Candela Technologies. I'm part of Candela since 1.5 years now. It's a great company. So far I have worked on different projects, including different customers for for Netgear, for Facebook. So there is one interesting project. If all of you are interested in that, we can talk about that also at the later part of this thing. The project is the Facebook project which we are working on, which is for open Wi-Fi project. So just for all of you to give you understanding of what we do here in Candela is, so basically Candela Technologies is the Wi-Fi testing company. So we create a equipment which test a Wi-Fi. So there are different companies like Netgear, Facebook, Cisco, who has routers available. Those routers are the same routers which we use in our home, but it's difficult to test them with real-time devices. So Candela is responsible for testing all of those equipments. We have different type of devices available, which creates hundreds and thousands of virtual client, a real-time traffic like TCP, UDP, all those kinds of traffic we run through routers, and then we do the testing like that. So that's all about me. Today, the topic I have discussed, I have selected is an embedded system. That's because I did my master's from embedded system, and after masters, I see a huge scope for embedded system in today's real-time world. So when I say scope, a scope means scope for jobs, for new innovations, and for new technologies to come in. So that's why I decided that let's go with the embedded systems, because a lot of students has very few understanding of embedded systems. So today we'll just discuss the overview of what's embedded systems, how it works, what are the different parts of embedded system, how it different from the system which we use. Okay, so those are the things which we'll discuss in today's call. Okay, any questions up to this point? Shall I start my presentation? Let me know if you can see my screen. Am I audible?
Yes, sir.
Yes. Okay. So all of you are able to see my screen?
Yes, sir. Screen is visible.
Okay. Thanks a lot. So basically, we will discuss following points. We will discuss what are the systems. Then we will discuss what are the embedded systems, classification of embedded systems, different applications of embedded systems, and what makes embedded system different. So in the last point, in what makes embedded system different, we'll talk about the real-time operating systems also. Okay, we'll have a detailed conversation, and it would be helpful if this is a two-way conversation where we all can interact with each other, so that all of you will have a good understanding. You can ask me questions, and we can do two-way communication also. Okay. So basically, what is the system? Okay, system is nothing but a way of working, organizing, doing many tasks according to a fixed plan and program, like program or set of tools. A system is also an arrangement in which all its units assemble and work together according to the plan or program. So the main example of the system is a watch. So as I said, that system is a thing or a technology which adheres to a certain specific rules, and that's called a system. A watch is a great example of that, where the rules are all needles move continuously in a clockwise direction, a thin needle rotates every second, a long needle rotates every minute, a short needle rotates every hour, and all needles return to original position after 12 hours. So when you say a system, or when you say that, when you see a watch, you have to see that it's not just a watch, it's a part of system, it's a system, because it adheres to a certain specific rules, and that's why it's called a system. If a technology is there, and if it's not obeying some rules, like if it's not obeying something as what we are seeing on screen, pre-specific rules, then it's not a part of system, or it's not a system. Okay, that's one thing. Now, what is an embedded system? Okay, so what you are seeing on in front of your screen is the block diagram of the embedded system. Embedded system is nothing but it includes a processor, it has a data memory, it has a different serial ports, parallel ports, also counters, interrupts, uh, clocks, output devices, power supplies, and all these things. Okay, so that's an embedded system. So basically, what is an embedded system? That's the question, right? So embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated functions, either as an independent system or as a part of large system. At one core, at the core, there is an integrated circuit. We can say it as the IC, which is designed to carry out a computation for a real-time operation. Okay. Complexities like it has different complexities. Complexities range from a single microcontroller to a suite of processor with connected peripherals and networks, from no user interface to complex graphical user interface. Okay. The complexity of embedded system varies significantly depending on the task for which it's designed. So in embedded systems also there are different type of systems. Okay, it's not the same system all over the world. There are different systems, like there are complex system, there are less complex system, there are more complex system. A simple example of embedded system is a microwave oven, or a router, or access point which you have at your home. All those are parts of an embedded system. Okay, now next question is how embedded system works. Okay, so embedded systems are managed by microcontrollers, or digital signal processor, and or ASIC, which is application specific integrated circuit, FPGA, which is field programmable gate arrays, GPU technologies. So these processing systems are integrated with components dedicated to handling electrical or mechanical interfaces. Okay, embedded system embedded systems programming instructions are referred to as firmware, are stored in read-only memory, which is RAM, or flash memory chips. Okay, so this is how embedded system works. Is it has a different integrated circuits, like ICs. It has different firmwares, it has different type of operating systems. So few of the operating systems which are used in embedded system are FreeRTOS. Okay, or there are also even a VxWorks which works for real-time operating system, or which works for the embedded system. Okay, then next question is the basic structure of embedded system. So basically, embedded system is the system which has a sensor, analog to digital converter, or digital to analog converter, or an actuator. So this also, it has memory, it has different type of chipsets available. If I want to show you an example of how, or of how or what could specify as an embedded system, then this can be a good example of that. Okay, so what STM32 board, this is the Raspberry Pi board, this is the STM32 board. All these boards are part of embedded system. If the definition which I told you, uh, if it has a different type of peripheral available, if it can work on the real-time operating system, if it does the dedicated job, then the system can be classified as the embedded system. Okay, next, the history of embedded system. So embedded system, so the first modern real-time embedded computing system was the Apollo guidance computer. Okay, it was developed in 1960s by Dr. Charles Draper at Massachusetts Institute of Technology for Apollo program. Okay, so the Apollo guidance computers was designed to collect data automatically and provides mission critical calculations for Apollo command module and lunar module. So if you search something for embedded system or examples for embedded system, you will get vast numbers of results like the applications. What are the different applications of embedded system? You will get a vast number of results. Like there is a microwave one, there is a missile guidance system. There are spacecrafts which work on embedded system. Few of the examples could also be from objects which went outside the earth. Some could be satellites, some could be Mars rovers, some could be uh, things like the Apollo guidance computer. Okay, so these are all the examples of embedded system. Example, the scope or vastness of embedded system. I am focusing more about the basic part about what are the applications there, because if there is application, then there is a job for this application also. Okay, so if if you have to study about embedded system, then if you once studied embedded system, or if once you get the understanding of how embedded system works, you have a vast amount of job opportunities open for you also. Okay, you can work in different domain also. For example, there are different domains, like we will talk about that in a future slides